All right, so today we are doing 1.6 and 1.6 is going to cover special types of functions such as the piecewise function. Okay, so piecewise defined functions, we're going to be working with linear piecewise functions. And then we're going to graph absolute value functions, and some of that may be reviewed for you. And then we're going to do the domain and range of those as well. So when you are doing your homework, the directions are going to be a little bit different. So I put a little note in there for you. So when it asks you to graph each function in your textbook, it's going to say to analyze key features. Okay, and when you're analyzing the key features, what I want you to do is to describe the domain and range and set builder notation. Okay, so for example one, when you are doing that on your homework, which again today I'll give you some, we're doing more graphing. So I made some more graph paper for you with the graphs already done. Make sure that you are doing the domain and range and set builder notation. You don't have to do anything other than that. All right, so with set builder notation, anytime you're doing the domain, you have to have X such that, and then there might be an inequality here. It might be all real numbers, but anytime you have set builder notation, you've got to make sure you have the right notation there, which is our fancy brackets, X such that, Y such that. Okay, and then this is a piecewise function. So the graph is going to follow 2x if the x values are less than 1, and it's going to be 4 if x is greater than or equal to 1. So what we do is we split that up into two different equations. So this is saying that f of x would be equal to 2x for a certain case, and f of x is equal to 4 for a certain case. So what I like to do is I like to make a table for each one so that I can graph it, and you have to pay special attention to the points that they give you. So if it's x is less than 1, 1 is going to be a key value, what we call a key value. That has to go here. Now, even though it's x is less than 1, you do have to include it on there. I'm going to talk more about that after we graph it, because that's the best way to show you why you have to include the 1. And then once you have your key value for that one, let's make sure you put your key value here. So again, it just happens to be 1. A lot of times they do overlap. Okay, and then I'm just going to put a star so that you know these are the key values. You always want the key values on your table. And then from there, you can just pick values in the interval. So if it says x is less than 1, numbers less than 1 or 0, -1, and then you could keep going if you wanted to. Okay, or you could just use your pattern. And then these are values that are greater than 1, so you can just do 1, 2, 3. Okay, and then we are going to find those points. So if this is 2x, you can find these by just plugging it in. So 2 times 1, 2. 2 times 0, 0. Okay, and then we can also see this is a linear function, so the pattern, it just keeps going down by 2. When you have a constant term and there's no x to plug in, if you were to plug in 1, there's nowhere for it to go, so it would just be 4. It's just going to be a constant term. And then when you plot these on the graph, you have to look at the symbols. So this is just less than. That means this is going to be an open circle here. Okay, so the less than symbol means you're going to have an open circle at this point on the graph. All right, and then this one here is going to be a closed circle. And again, that is because of this equal to symbol. All right, so let's graph the line. So the only place you're going to have an open circle is at this key value, 1, 2. So at 1, 2, you're just going to put an open circle around that point. And then everything else is just a point, okay? So you can think of it like a closed circle. It really just is like what we were graphing yesterday. Okay, and then we're going to use our straight edge to connect. You could keep following the pattern using your slope. That's perfectly fine. You can also just use your straight edge. And then again, you just want it to span your grid. Okay, so you're always going to span the grid that you have. One thing I like to double check is, if the slope is positive, I know that the linear function should be going up from left to right, so I like to make sure that I did that correctly. And then if you have a constant, you know it's a horizontal line. So when you're graphing this, you're at 1, 4, that's a closed circle. Again, the rest are just points on this line here. Okay, so this is just a horizontal line. Okay, when you have a horizontal line, a lot of you are just going to be able to do this without putting all those points on there. Just make sure that you're paying special attention to whether it's an open or a closed circle. Okay, so now we're going to go back and talk about why you have to put 1 on there. So if it's x is less than 1, you can't just start at 0, 0. If you were to start at 0, 0 right here, you would be missing this whole part of the graph. There's an infinite amount of points in between there. So the way that you show that it doesn't include that, but it includes all those points in between, is with an open circle. And so that's why you have to include the 1. Okay, if you didn't, you'd be missing that whole chunk of the graph. All right, and now we're ready to do the domain and range. So this should look familiar to some of the domain and range graphs we've seen before, because this is a function that's neither continuous nor discrete. So we did some of those before. Remember, when you're doing the domain, you're looking horizontally at the x values. And a lot of times when we did this in interval notation. For this section, we're going to be using set builder. And then if this line keeps going, okay, that means your x value is headed to negative infinity. And then you're looking for anywhere there's a gap. So remember, there's no gap here because this is going to keep going. And then the only potential area I would have a gap is here. But can you see how these overlap? You have an open circle, but then you have a closed circle. So if you have that overlap, there's not going to be a union. This is just going to go from negative infinity to infinity. So how do we say that in set builder notation? Negative infinity to infinity. Great. So x such that x is an element in the set of real numbers. Okay, so we have to make sure we know how to say that and how to use those symbols. All right, and then for the range, I'm going to let you guys use y for the range. Because this is f of x, you might also see answers that have f of x such that I think it looks kind of messy, so I'm fine with you continuing to use the y. And then again, you are always starting with the lowest, and then you're going to the highest. So the lowest y value is negative infinity, and then we're just following this up. You do have a gap here. So this is going down to negative infinity. So you have this section where all the points are at 2 or below. And then you have this section where all the values are at 4. Okay, so if it's negative infinity to 2, that means all the points are below 2. So the way that we would say that is y is, and then in this case, see how it's an open circle? So if it's an open circle, do we have an equal to or not an equal to? Not an equal to. So an equal to will have the closed circle, and this is just going to be y is less than 2. Okay, and if we were doing interval notation, there would be a union here. Because we're doing set builder, we're going to use or. And the only other value it can be is 4, so it would be y equals 4. Okay, so anytime there's a gap, remember, that's the union, and then the way we say that with set builder notation is going to be the or. Okay, can you guys think of any questions you have for me on part A? I know that was a lot of information. All right, so with part B, we have 1, 2, 3 equations. Okay, so again, the first thing I always do is I just separate the equations. So I have g of x is x minus 3, g of x is negative x, and g of x equals 4. Okay, and then when I'm deciding what I want to put on my table, I'm always looking at my key values. So for x minus 3, my key value is negative 2. And then I also just like to put whether it's open or closed. So if there's an equal to, it's going to be closed. I just do that right away because there are so many steps in this process. I want to make sure that when I go to graph, I'm not forgetting about that. And I don't like looking back up here, so I just make myself a note. Okay, if there's no equal to, this is an open circle, and this is an open circle. Now, because this goes from 0 to 2, I have 2 key values that I have to include. That's going to happen when you have more than 2 equations. And then the last one, I have to put the 3 on there, and that's going to be a closed circle. All right, so this says x is less than or equal to negative 2. So I just pick values that are less than negative 2. So negative 2, negative 3, negative 4. And then you're just substituting them into your equation here. So negative 2 minus 3, negative 5. Negative 3 minus 3, negative 6. Okay, and then you can see you have the slope of 1, which is affecting your y value. Now this says x is between 0 and 2, so I would just put 1. You can use decimals like 1.5 if you want to. And then this is just the opposite of what you plug in. Well, the opposite of 0 is 0. The opposite of 1 is negative 1. And the opposite of 2 is negative 2. And then the last one, it's 3, so just 3, 4, 5. Anytime it's a constant, you know that that's going to be your output value. All right, and then let's take a moment now and graph those. So I have negative 2, negative 5. I know that's a closed circle. And then again, these are all closed. The only ones you have to worry about are the ones that are your key values. And then once you put a few of those points on there, you can just go ahead and use your straight edge to help you span the graph. Okay, and then you have an open circle at 0, 0. You have an open circle at 2, negative 2. And then this is just your dot in the middle. And then you're just going to connect those. Okay, so just because these two are open doesn't mean you put an open one in the middle. Okay, the only places it's open are at those key values there. Okay, and then you have 3, 4, which is closed, and then you know the rest of this is just going to be a horizontal line, so you can just go ahead and continue it there. All right, so then let's figure out what our domain is. So again, this arrow is going to continue to negative infinity. And then I do have a gap in between these two. So this interval goes from negative infinity to negative 2. And then you have a gap. It picks up again at 0, then goes to 2, and then you have another gap. It picks up again at 3 and goes to positive infinity. Okay, so if we were writing that in interval notation, it'd be very simple. You would just have to remember the soft bracket for open circles, the closed bracket, or for closed circles, you have the hard bracket. Okay, for the set builder notation, we just have to write inequalities. So if it's negative infinity to negative 2, that means you have all of these points that are less than negative 2, and then if it's equal to, it's a closed circle. So it's going to be x is less than or equal to negative 2. Okay, and then we're not going to use the union. We would do that if we have the interval. So it's going to be or, it's going from 0 to 2. Notice that those are both open circles. And some of you might start to realize a connection. We're going to talk about that as well. Or it's 3 to infinity. So all the values of x would be above 3 or equal to because of the closed circle. Does this look familiar to some of us? Where is it? Yeah, so this happens when there's no overlapping. Do you see how none of these intervals overlap each other? If they don't overlap, they should match. You see how this interval is here, this interval is here, this interval is here. That will happen if they don't overlap. Okay, it didn't happen in this first one because they overlapped. So we had to do the whole thing. Okay, but if they're separated like this, they're already separated for you. Okay, and then for the range, again, this arrow is continuing to go downward, so you're at negative infinity there. Okay, and then you're at negative 5, and all the values below that are your y. Okay, and then we have a gap, and this is our next interval. So on the y's, you just look to where it corresponds. This would be 0, this would be negative 2, and then you have another gap, and then it picks up again at 4. That looks like negative 4, and I don't like that, so I'm going to draw a heart. If I make a mistake, I draw a heart. Okay, so it's just going to be it equals to 4. And then, do you guys notice any of these values appearing anywhere? So you have 0, negative 2, negative 5. They're the what? Yeah, they're just the y values for the key values. So you have negative 5, that's your key value, the y value. 0, negative 2, 4. So they're the y values for your key values. Okay, so the way that we would say that is y is, so it's a closed circle, so it's going to be less than or equal to negative 5, or it's in between negative 2 and 0. The negative 2 has to go first because it's lower, it's the lower number. And then you're just going to have less than because of the open circles, or all the points are, in this case, equal to 4. Okay, and then what questions do you guys have on this domain and range?
Why is it negative 2 less than 1?
Oh, sorry, I put 2 and it should be 0. Thank you. Yes, so negative 2 to 2. Negative 2 to 0. Good. Is there anything else? All right. Now there is a rare thing that happens. Sometimes an open circle and a closed circle overlap at a key value. For example, if this was moved down here and the closed circle overlapped with the open circle, it's the closed circle that takes precedence. So if they overlap at a key value, the circle is closed. Okay, so if you ever have an open and a closed circle that overlap, okay, the circle is a closed circle. So don't make a target, don't do a closed inside the open, it's just going to be closed. You can just fill it right in. All right, so we graphed those piecewise functions. The next thing we're going to do is we are going to actually make one. So based on a story problem. So Tony's going to purchase new ribbon for his crafting projects, and he's going to pay $8 per roll. Okay, if 4 or fewer are purchased, $6 per roll. If 5 to 10 are purchased, and $4 per roll if more than 10 are purchased. So we are going to write a piecewise function describing this cost. So we're going to do f of x equals, and then this is like a big fancy bracket. We're going to do like a swoosh, swoosh. Okay, and so what we have to do is come up with an equation, and then it's always if, and then you have to say what the restrictions are on the x value. Okay, and I put 3 ifs because I know that there's 3 different cases. We highlighted those. Okay, so the cases are, it's $8 if 4 or fewer are purchased. And then the next one will be 5 to 10. Then we have more than 10. Okay, so really this is telling you how to write it. How do you write more than 10 rolls? It would be x is, and then what symbol should I use? Yep, greater than 10. Okay, and then this is for 5 to 10 rolls. So it would be 5 is less than or equal to x, which is less than or equal to 10. Okay, so if it includes 10 here, it can't include 10 here. That's why you are not going to put the equal to with that, because it'll be more than 10. And this says 4 or fewer. So that does include the 4. So x would be less than or equal to 4. Okay, now when you're thinking about what your equation should be, we know that $8 has to play a part in that. So generally, there are a couple of different variations I get for that. One of them is 8, so $8 if x is less than 4. So if you just have the 8, that would mean your total would be 8 if you bought anything less than 4. So if you buy 3 rolls, it's not going to be $8, it's $8 per roll. So what do I have to include with it? Yeah, you have to have the x. Anytime you see the per, right, per roll, like in this case, x is the roll, you're going to have to multiply. So that means that this one will be 6x, and this one will be 4x. Okay, that way if x is 2, you know you're paying $16 and not 8. All right, and then we get to do the calculation. So what's the cost of purchasing 3 rolls of ribbon? So you would find where the 3 fits in. So 3 is less than or equal to 4. So you would just have to do the $8 times the 3. Okay, and then will you guys go ahead and do the 6 for me? Okay, so 6 should fit into the middle interval. So 6 rolls at $6 cost how much? $36. Okay, some of you may remember how to graph absolute value functions from Algebra 1. Does this shape of a function look familiar to you for absolute value? The V shape? Some of you are looking at me blankly, so I'm going to assume that no, we need a refresher on this. Okay, so the absolute value function technically is a piecewise function, which is why the book includes it in this section, because when you're doing the absolute value, it includes all of the values of x that are positive, and then it transforms those values of negative x into a positive value, and so you can use a piecewise function to define it. Okay, in function families, we have something that is called the parent function, and the parent function is always the simplest of the functions in a family, and the simplest just means there's no transformations or translations. You talked about translations in geometry, right? 4 units up, 3 units over, that type of stuff. And just like a parabola, an absolute value function has a vertex. Okay, so what you see as the parent function is f of x equals the absolute value of x, and we can calculate using that. Okay, and then the calculations are x if it's positive or 0, and then the opposite if x is less than 0. Now the domain for the absolute value is all real numbers. So when you're writing that in set builder notation, you are always going to write it like this: x such that x is an element in the real number set. And then all non-negative real numbers. So if they're not negative, that includes 0 and all of the positive values. So the way you would say that for your range is all values of y such that, you guys could tell me what it is? Yeah, and yeah, good. Greater than or equal to 0. Okay, and it's equal to because it does include it. Okay, now this is going to change depending on the function, but for the parent function, this is always true. Okay, and then I said create a list of what you already know about absolute value functions. So you know if it's absolute value, your solution is always going to be what? Positive. And then do you guys remember what the official definition is? Like why it's always positive? What does it calculate? I know, but it measures something specific. It's going to be the distance from what? 0. Okay, so the distance from 0 is why it's positive, because your distance is always going to be positive. That's why the negative and the positive values are going to be the same. Okay, and then you may not have remembered this, but I just showed you what the shape of the graph is. It's always going to be shaped like a V. Okay, and it is also symmetric. So it's the same on both sides. It has line symmetry. Okay, now you might not always graph it just directly in the middle there because it's not always going to be at 0, 0. But if you were to continue that grid, it would be symmetric. All right, so let's graph a few of these. And then we're going to state the domain and range in set builder notation. Okay, so I broke this down for you into 3 simple steps. So the first thing that you want to do is find the center of the absolute value. That's going to make the graphing very simple. So to find the center, you set the inside of the absolute value equal to 0, and you just have to solve that for x. Okay, and you're only going to take the inside. Okay, so for part A, we have h of x is equal to x minus 7. So x minus 7 is what is inside the absolute value, and then you would just solve using algebra. So add 7 to both sides. So this is the center x value. When you create your table, you're always going to put this value in the center. So we're going to put x equals 7 in the center. And then we're going to go 2 units left. And 2 units right. Okay, so that will give you a very nice graph. So the 7 is going to be the vertex. Sometimes I'll box it in. So if you go 2 units to the left, it'll be 7. And then if you go down 1, down 2. Do you guys remember why 6 was scared of 7? 7, 8, 9. So you do 2 up. That's your dad joke of the week. Okay, so 5, 6, 7, 8, 9, and then to find your y values, all you have to do is plug it into your original function. Okay, so if you plug in 5 minus 7, it's the absolute value of -2, what's that going to be? Yep. You plug in 6, it's the absolute value of -1, which will be 1. Okay, 7 minus 7 is 0, so the absolute value of that is going to be 0. 8 minus 7 is 1. 9 minus 7 is 2. And then because we did this in the center, do you guys notice that your y values are symmetric now? Okay, so if you pick the center value, that's what makes it a little bit simpler. Okay, and then when you plot your points, after you do that, you can find your domain and range. Okay, so we're going to be at 7, 0. 8, 1, 9, 2. Okay, and then again, we're just going to span the grid. So this side, it is going to be shorter. You could keep going. It really is 2 linear functions that come together to make the v. Okay, so you're just going to span whatever grid that you have there. Okay, and then anytime you're doing the domain and range, remember, it's always the lowest to the highest. That's the order it has to go in. Remember that we just talked about the domain is all real numbers. Our graph verifies that. This is going to go to -infinity. This side is going to go to +infinity. So it's x such that x is an element in the real number set. And then for the range, what is your lowest y value? 0. And then your highest, infinity. Okay, so all of the values are above 0. Are they equal to or not equal to? It's going to be an equal to or just greater than. Be equal to. So if it's a point, right, it's a closed circle, so it'll be y is greater than or equal to 0. Okay, so I want you to do step 1 for B and then see if you can set up your table. Okay, and that one is a little bit harder, so just give it a go. Okay, so when you're finding the center, you are only taking what's inside the absolute value. So what's inside your absolute value? What's the only thing that's inside your brackets here? Just 4x, right? So you don't have to take anything else. It's only what's inside. So we're going to take 4x, set it equal to 0. So we would divide both sides by 4. X is going to be 0. And so that's going to go in the center of our table. And then we can just go 2 up, 2 down. All right, so if you plug in -2, part of this you can just do in your head, right? You plug in -2, -2 times 4 is -8 minus 1. So when you do the absolute value of -8, you get +8, but this is multiplying it by a -1. So this is -8 minus 1, which is -9. Okay, and then when you plug this in, 4 times -1 is -4. So when you take the absolute value, it's +4. But when you multiply that by the negative, it's -4 minus 1, so you have -5. When you plug in 0, this is -0 minus 1, which is just -1. And we know that if this is the center, these should be symmetric. So when you plug in 1, you have -4 minus 1. Yep, that's going to be -5. 2 times 4 is 8, so you have the opposite of 8, minus 1. And then we can plot our points. And we can see now that the direction is going to change. And if it's symmetric, just if this is 1 away from the axis, that'll be another 1 away. It's wherever your line of symmetry is. Okay, so now this is opening downward. So that is going to affect our range. Okay, your domain, this is still going to infinity, negative infinity, and infinity. So your domain is still all real numbers. Okay, and then your range, if you look at what's happening here, all of your y values are below what value? Yep, so all points are below -1. They're here and below. Okay, so that would be y such that y is less than or equal to -1. Okay, I'm going to give you time to work on this, and then I have graphs for you, so I'm going to pass those down.